Hmm.
when my father, the CEO of our company, left Woods Hole Oceanographic Institution, where he was working under Robert Ballard, the guy who found the Titanic. We know more about space than we know about our own ocean. And in the 80s, he started Scientific Incorporated. They specialized in making CTDs all the way up until the 90s, where they invented DT 705 CTD, which is a conductivity temperature depth sensor used on every fast attack submarine and U.S. submarine in the fleet, and still is used today. So we're the
Mm.
first company in the world that doesn't have to pump the ocean water through this glass cell, which makes our glass cell much, much shorter, much wider.
Hello, everyone. Welcome to another episode of the Quiet Work Podcast. Today, we are going to talk about the secret technology that keeps the military fighter jet from falling out of the sky and also guides the U.S. Navy submarines through the deepest parts of the ocean. And I don't have to tell you how curious I am about this conversation. Without any further ado, Dean, please introduce yourself and tell us about the company you represent, and we'll start a conversation with that.
My name is Dean Fougere. I represent D2 Incorporated. We are a defense contractor and a commercial manufacturer of a variety of equipment. We do jet fuel conductivity sensors, petroleum expeditionary analysis kits, particle counting for the fuel side. And for the ocean world, we make conductivity temperature depth sensors, commonly known as CTDs, which measure the saltiness of the water, the temperature of the water, and the depth that various vehicles are operating in.
Incredible. So you cover the ocean, you cover the sky, and you work with the US government or the department, making sure we're all safe here. Take us back to the beginning when you first joined the company, and maybe even the beginning of the company, since this was just a few years before you joined as an intern, as we discussed last time. So take us back to 2004 to 2008. What happened and how this company even came to exist?
Yeah, so I think maybe we'll go back even further than we started yesterday. The company was originally founded in the 1980s as Falmouth Scientific Incorporated
Hmm.
when my father, the CEO of our company, left Woods Hole Oceanographic Institution, where he was working under Robert Ballard, the guy who found the Titanic, and he was working with another person named Neil Brown, who was the original inventor of what's known as a conductivity temperature depth sensor. And in the 80s, he started Falmouth Scientific Incorporated, and they specialized in making CTDs all the way up until the 90s, where they invented what's known as the DT 705 CTD, which is a conductivity temperature depth sensor used on every fast attack submarine and U.S. submarine in the fleet, and still is used today. And what that sensor does is it allows the Navy to determine the density of water and also the sound velocity of water for use in sonar applications. You need to know the sound velocity in order to determine distance to target, and you need to know the density of the water so that if your fast attack submarine is operating in brackish water or river delta, it allows them to ensure that the submarine does not accidentally pop up on the surface when doing something like deploying Navy SEALs near the coastline. And then in 2004, D2 Incorporated was started when Alan left Falmouth Scientific Incorporated, which is still a business operating today, and created D2 Incorporated. And when that happened, he took the industrial process sensors, which were inline conductivity sensors that were made to measure the conductivity of fuel inside pipelines, which the company Shell came to FSI to develop. And when Alan left FSI, which we are no longer affiliated with, he took this technology and started D2 Incorporated with inline conductivity sensors that are measuring inside the pipeline. And the reason oil and gas companies want to measure that is because when you move fuel through various systems like refineries or large fuel terminals, the fuel builds up a static electric charge. And what happens is that charge builds and builds and builds until it discharges. So if that happens in a vapor filled space, which has happened at an ExxonMobil facility in the recent few years outside Chicago, what will happen is it can blow up a fuel truck as it's filling with fuel at a fuel terminal. And that's where the big oil trucks you see on the road go to fill up. Then they deliver that out to the gas stations that you see. But we have inline connectivity sensors now installed at all the Exxon Mobil facilities across the country to
Hmm.
ensure that that fuel doesn't go too low so that the static electric discharge can dissipate. The other issue that can happen is if you put too much of the additive into the fuel that raises the conductivity of fuel, then the gauges in an aircraft can be messed with and stuff like that because the fuel is too dissipative. So we make a sensor that measures the fuel and ensures that the fuel is within a specific range. So you don't want it too low or it can discharge via a spark and blow up a fuel terminal or a truck. And you don't want it too high because then it will mess with the fuel gauges. And from there, we also develop the injection systems that inject the additive that's made by other companies into the fuel in order to keep it within that range using our inline sensors as the control for those injection systems. And that's how D2 got started. And then from there, we moved on to making other equipment by either purchasing existing technology and then reworking it to make it smaller and digital and things of that nature. And also by developing our own ASTM standards that have really enhanced the ability of the fuel industry and the US military. For example, we make a free water detector, which determines how much free water is in jet fuel. So when they are using jet fuel on a ship like a destroyer, when they're filling up a helicopter, or they're using it on an aircraft carrier, what they do is to maintain ballast is they fill the jet fuel tanks with seawater. We make a free water detector, which determines how much free water is in jet fuel. So when they are using jet fuel on a ship like a destroyer, when they're filling up a helicopter, or they're using it on an aircraft carrier, what they do is to maintain ballast is they fill the jet fuel tanks with seawater, and then they
Hmm.
pull from the top of the tank because jet fuel is less dense than ocean water. And then they run it through a bunch of filters. And then once it's been run through the filters, the final check to make sure there's no water in the fuel is our little device that, they run 500 milliliters of fuel through a test pad. If there's any free water, it changes the color of the dye on the test pad. And then our little device gives them a parts per million number, and as long as the fuel is below that number, they can use it in the aircraft. It's safe for use. So we're keeping the military safe when they fly. This is now used across the Air Force, the Navy, the Coast Guard. Any U.S. military ship or Coast Guard ship that has anything flying off it, like a helicopter, uses one of our devices. And then because that was so effective, the military gave us a very large contract to produce what's known as a petroleum expeditionary analysis kit. This is a kit with 6 different lab tests inside of it, but it comes in a hardened case with the batteries inside the case so that you can run everything in the case. And this is the first time militaries had something like this, because they used to have to bring all of these in separate individual cases and not be able to run these in the field and things of that nature. So what we did was, in this case, which has like density, particle counting, flashpoint testing, fizzy, free water, and connectivity, basically allows them to certify the fuel anywhere in the world that it's safe for use on aircraft that are landing on aircraft carriers or in Humvees or Abrams tanks. So the US military can use this whenever they want to capture fuel in order to certify the fuel safe for use in those vehicles. And we provide these to the US Marine Corps, US Air Force, US Navy, and the Coast Guard is going to be adopting this technology soon. Also, other militaries around the world are now starting to use this as well. We just had a news article on our website about how the Air Force is training the Argentinian Air Force on the use of these
Wow.
peak kits. So this is a NATO-wide technology that's being implemented. And one of the benefits to them is, say your helicopter has a 600-mile range. If you're using the peak kit on board, it can fly twice the range until the aircraft is completely empty of fuel. You can use captured fuel out in the field to get back to, say, the aircraft carrier. And then when they land on the aircraft carrier, they can keep the aircraft. They don't have to dump it over the side of the aircraft carrier because they know the fuel on board the helicopter that they captured is safe, and therefore it can be refueled on the aircraft carrier. Where in the past, if they did that, they would have to dump the helicopter over the side of the ship because they weren't sure that they could add that to the fuel system, right?
Yeah. Wow, fascinating. I was reviewing my notes. The PEAK stands for Petroleum Expeditionary Analysis Kit, correct?
Yep,
Just for
absolutely.
someone who would like to look it up, because peak might give you different results on Google, I can imagine. But if you
Yeah.
look at a petroleum expeditionary analysis kit, you'll find it out, or you can go to the website. We'll link it down below the video. But that all sounds so fascinating. Obviously, I'm not a sensor expert, not in that area, of course, especially. But as you were describing it, I just could see the movies flying through my head. Being on those big ships, seeing those jets, helicopter flying around, and obviously now that even other countries are using that or looking into that, using that technology or already using that technology, it's just mind blowing. So if you could share a little bit more. In the beginning, you've mentioned around 2004, if I remember correctly, that Exxon Shell approached you to develop, or your father, the company, to develop these sensors for oil refineries back then. Is that how does one essentially, was that because of his previous experience in that space? Was he known for it? And that was the reason why they approached him, or the company back then? Because obviously, normally when you start a company trying to fight for those first contracts, it's not like you immediately start selling or partnering with this large corporation. So how did that relationship develop, or how was that initiated back then?
So back then, we were one of the only companies in the world that was making
Mm,
CTDs. So oceanographic sensors that measure conductivity in the ocean, which is how you determine salinity. And that's how salty the water is. So
mm,
they came to us because there was no true real time inline conductivity sensor out there. There was a system that basically sat parallel to the pipelines, and it would take a sample with a pump, send it out to a system, measure it, and then put the fuel back in the line. But ours literally sits in the pipeline and measures in real time as the fuel is passing the sensor. And we are still the only company in the world with one of those. And it's listed in ASTM, which is the test method for determining the electrical conductivity of distillate fuels, which means you can use our sensor to certify your fuel for conductivity in real time. So there's a lot of places in the world. I personally have gone out and done the field calibrations for all the Exxon Mobil sites across the entire country, from Montana to Chicago to Baton Rouge. And basically, at all those facilities for Exxon, they're measuring in real time. And then when the truck driver gets his bill of lading, it's written on there that the fuel was certified within this range. So he knows it's been loaded safe. And that's our success with all of this, the peak kits and all these other things, is why in 2014, the US Navy came to us because we had gotten out of making ocean CTD sensors in 2004. But in 2014, because once we left the CTD game, there was really no competition for the one company making CTDs out there. So in 2014, the US Navy came to us with an SBIR, which is the military's like, we have a problem and we want people to solve it. Anyone can apply for the SBIR, but we were the ones that were awarded the phase one, which is basically they say, okay, your technology looks like it might have some sort of success. And then we brought it to phase three, which means we provided them 9 prototypes to get to phase two that worked. And then in phase three, that's when you go commercial with the technology. So not only is it accepted by the military, but it's also accepted for commercial use for everyone. And that's how we got back into making CTDs with a brand new technology that we feel and has now been proven by a third party, which is Woods Hole Oceanographic Institution, to be the most accurate CTD in the world, which allows for oceanographic research to be improved. It allows for naval operations to be improved because these CTDs are extremely important for like sound velocity determination, which improves the ability of sonar to work underwater. A lot of people don't realize this, but when you have interface changes in the ocean, such as like thermohaline changes, basically when the temperature changes rapidly in various places, it's an easy place to hide like a submarine or an AUV or a UUV because when the water changes, it changes the sonar profiling through there. But if you can determine what that change is with oceanographic equipment like a CTD, then you can really improve the ability of your sonar to read anything that's in those interface change areas, right? So
Wow.
a lot of this information that CTDs gather is not just relevant for like climate change studies because it's measuring the temperature of the water and the salinity of it, but it's also measuring extremely important information for the Department of Defense because it allows them to improve their ability to measure these interface change areas in the ocean.
Wow. And you've also mentioned that the climate, the ocean climate impacts our climate here on Earth. So that's another reason why this technology is so important to continue to develop and
Yeah, it's important because the ocean currents, especially like for example, in America, the Atlantic Meridional Overturning Circulation, known as the AMOC, these large ocean currents are changing. A lot of people think, for example, that the AMOC is starting to collapse. And when that happens, basically it'll start the next glacial period. The glacial period is like an ice age, lasts like over 10,000 years in some cases. And places like Iceland have now declared that the collapse of the AMOC is a national security threat because Iceland will become about minus 60 C if that were to happen. And things like that, like London will be minus 40 degrees C. And then
wow.
the more like middle latitudes, because basically what the AMOC does is it takes tropical ocean water from down near the equator and sends it up into the Arctic regions, and then it sinks and becomes cold water, and then it travels back down to the tropic areas, keeping them more moderate than they would be if this large ocean current wasn't happening. So it heats up the northern latitudes and it cools down the middle latitudes. But if it collapses, what happens is the middle latitudes become extremely, extremely warm, and the northern latitudes will become extremely, extremely cold. And this isn't something that like we can stop from happening. So it's really important to measure these types of things using extremely accurate oceanographic, instrumentation such as our CTDs. And we don't know that much about the world's oceans. We know more about space than we know about our own oceans. So it's really important for everyone that we start focusing more on what's going on this planet and start to measure these things, especially in the ocean.
Speaking of global warming, absolutely. Yes. And we had this winter in Poland, I think it was, there was a day or two where recorded minus 36 Celsius this year. So that's not far away from minus 40 or getting to minus 50 or 60, which is happening in some parts of Russia. I've watched a documentary on that. And obviously, this is the time where everything shuts down, and it's pretty difficult to operate and function for everyone in that type of climate. So, very, very important. I'd be really curious to hear, how do you go about developing and testing this technology? Like, do you have to constantly, or someone on your team has to constantly travel to these sites and keep testing, iterating, and finding out how to improve that? Or does it happen in a closed facility that you have on site there?
Yeah, the best way to test all the technology is to put it out in the field. And generally, we rely on third parties to do that. So,
Mm,
one of the early adopters of our new CTD technology was Woods Hole Oceanographic Institution. And they worked with people like the Bermuda Institute of Science, and they put it out on the Go Ship program with BIOS and also up on the ice tethered profilers. So, if you go to HUI-ITP, or you type in Woods Hole Oceanographic Institution ITP program, you'll come up with their website, which is outputting data in real time from these ice tethered
mm,
profilers. You can see it now. And basically what an ice tethered profiler is a autonomous vehicle that is like a long tube, and our CTD is the only sensor on it. And what they do is they go up in the Arctic and they drill a hole in the ice and they deploy the ITP down through that hole in the ice. It goes down to the bottom of the Arctic Ocean. And then once it gets to the bottom, it knows it's there because the depth sensor on our CTD tells them you're now at the bottom of the ocean. It then starts to come back up. And as it comes up through the ocean, it takes a profile of the Arctic Ocean from the bottom of the ocean all the way up until it hits the ice. And because the depth sensor is extremely accurate down to, within zero point 0.1 meters, like 0.001 meters. It allows them, when it hits the ice, to not only measure all of the water below it with the CTD, the conductivity and things of that nature. It allows them to measure the depth of the ice, because when it hits the ice, it then says, okay, now at ice level, and that's how deep the ice is. So it can measure how salty the water is there as well, which tells them how much ice is melting. And then it tells them the depth of the ice, which tells them, how much ice is melting again. And then it sends out that data via Iridium satellite through the ice. And once it's done that, it goes back down again and measures over and over again doing this until the battery in the ITP sensor dies. And then the whole thing just sinks to the bottom of the ocean forever. But one of the things we were able to do was lower the power draw on the CTD that we installed in these to extremely low power, which allowed them to extend the battery life of their tethered profiler for multiple more trips per ITP sensor. So basically, we helped them gather more data by extending their battery life.
And there's a website you said that you can look it up, or is it like live?
Yeah, it's live now. So if you go there, you'll
What's
see
the web?
it's a Woods Hole Oceanographic Institution ice tethered profilers. And if you pull that up, it'll pull up their webpage and you'll be able to see their program in real time. They've also now developed tethered ocean profilers as well as part of it, which we're also on, which are ones that they retrieve. So not all of them sink to the bottom of the ocean anymore. Some of them they're now pulling back up through the ice and taking back and refitting and then redeploying. But these are spread all across the Beaufort Gyre, which is up in the Arctic Ocean. Some of our sensors are on top 22, which is right off the coast of Russia. Yep.
Wow.
That's
So
the
that's here?
program there. The one you're looking at on the screen there is one of the top program ones. So that's a tethered
Mm,
ocean profiler, which means they're going to retrieve that one after they deploy it.
that's
But we're
incredible.
not the only company on that program. We have, I think, 5 now deployed with them, but they have like a lot of those up there.
That's incredible.
But that was we just had a paper come out that's now digitally published with the Journal of Atmospheric and Oceanic Technology that was written by Woods Hole Oceanographic Institution. And they took data from that ITP TOP program up in the Arctic. And they took data from the BIOS deployments on the Go ships that basically show that our sensor is as accurate as any other sensor in the world. And we're the first company to be able to produce a sensor that can meet those specifications that does not have a pump on our sensor. So if I show you here, this unit here is like one of our ones we've developed for Teledyne to go on their gliders and for other AUV, UUV systems. So basically it would sit inside of the vehicle. And the only thing that would be sticking out is this top plate, which they can change to match the diameter of the AUV. And this glass tube here, which has plugs in it because it's filled with the ocean water right now. But it's basically a little glass tube. And that glass tube is the conductivity sensor. So we're the
Mm,
first company in the world that doesn't have to pump the ocean water through this glass cell, which makes our glass cell much, much shorter, much wider, which allows it to be free flowing, which has a bunch of advantages like much lower power draw. We don't have a pump that breaks, so you never have to worry about the pump breaking on our system. And it makes the system completely silent. So for military
wow.
applications, there's no moving parts, which means if it's on an AUV, it makes the AUV even more quiet while still giving it the same extremely accurate connectivity data that you would get out of a pumped CTD.
Incredible. How many people do you have on your team right now? How many researchers and how many people work on those prototypes and new products that you develop technology?
So we have a team of 25 people now, and we do about $30 million a year in business. And, most of the team here are engineers. We do manufacture a lot of this stuff. So we have about probably 8 assembly people. And then
Hmm.
everyone else here is an engineer or a self-trained engineer like me. I've just been at this since 2008. I don't do the design personally, but I do all of the marketing for the company and I give all the
Tell us about your role. How did it start? Because I know the first 2 years were very exciting for you.
yeah. So I was originally a political science student, and
Mm.
I was going to go work for the Department of Defense doing like, or maybe the State Department out of college doing, political analysis. But I took a sail from Cape Cod down to St. Thomas with my dad. He has a big sailboat. And he was
Oh,
like, why don't you come and just give a whirl working for D2 and see if you like it? Because our sales guy at the time in 2008 just left the company. So I was like, I'll give it a whirl. And the company at the time was only, very small. So I started as an unpaid intern for a year. And after about a year and a half or so, we got the company up to a pretty decent large number of sales per year. And then I started as a full time employee. But I've been working for D2 since 2008. When I joined, they didn't even have like a website or anything of that. They did no marketing at all. They just thought the technology, it was two engineers. They just thought the technology would sell itself. And I was like, no, let's market this and, try to get more customers and things like that. And it's been, a really fun time. It's been a really good time, but been a large amount of learning experience for me over the way. I've now done every job in the company, from doing assembly work to helping them come up with ideas for designs. Now I run the entire oceanography department of the
mm.
company. I'm going next week to do a pretty large technical talk at Oceanology 2026, where I'll be presenting this paper written by Woods Hole Oceanographic Institution that shows the accuracy of our sensor compared to the industry standard pump CTD out there.
Wow, that's just incredible. And I'll be curious to hear in your field, in your industry. You've mentioned being in sales and marketing from pretty much from the beginning, because that was not existent back then. How does one grow a company like yours? Do you focus heavily on developing new technology as the interest grows, or do you actually go actively after certain companies? And maybe if you had Shell and ExxonMobil, maybe another oil company or another country. Like, how does one grow a company like yours?
Well, we started out by going to things like ASTM, which is a meeting that happens semi-annually, and other things like the International Association of Safe Handling, which is another big technical conference. And I would present papers, technical papers that were not aimed at sales, but it was the byproduct of presenting your technology to these key industry players, is that they approve of it, and then they tell the people down the line, you need to use these connectivity sensors to make sure the fuel is safe, or you need to use these handheld sensors, etc. And we've really focused on trying to interact with people and figure out what they need and why. So, like, a lot of the fuel terminals use handheld connectivity sensors. And one of the things they would have to do is semi annually, they would have to send their handhelds in to the other company that makes it and get them calibrated. So, we developed a handheld that comes with a calibration box. And the calibration box only has to be calibrated once every 5 years. And if you have one of these boxes, you can calibrate as many of the handheld connectivity sensors we make as you want. So if you have like a
Um,
fuel depot for the military, you have one of these boxes there, and all of your handheld meters can get calibrated on that box. And then you either just replace the box after 5 years or you send it back to us for calibration. But they can do all of the calibrations and verifications of the cal in the field, which really enhance their capabilities. And for things like the free water detector, I went on the internet and the military had written an article about how the free water detector they were using was obsolete because it was an analog device. It was very hard to use. Your average 18-year-old warfighter was not very good at using these things. So we developed a digital version of that that's
mm,
automated and 4 times more accurate. And I went out to contacts I had made at Wright-Patterson Air Force Base with the Air Force, and once they had seen this technology in person, they then recommended its use to the other parts of the military. So basically, and we met these people at things like ASTM and IASH. So basically, you have to go to these technical conferences and make connections with people and then use those connections in order to get them to take a look at your technology. And then
Mm.
once they approve of it, you can get it to, a larger market.
Absolutely. So a lot of networking, going to those events, meeting people, and obviously being really good. I mean, not really good. There's no level if you're the only one at some of the technology to develop in the world. So you are absolutely the best in that in what you do. So obviously that helps as well. And
Yeah.
then that takes care of itself. And then the compounding effect of doing great job delivering great technology over and over again, year after year, that speaks for itself. It essentially became a paragon of reputation in what you do. So that's just incredible, mind blowing. You've mentioned that a lot of website visits happen from or are coming from YouTube. Tell us about your YouTube endeavors. We'll promote it here as well.
Yeah, so that's the other important aspect of running one of these companies is you have to have good online presence. So I've
Hmm.
always been the person who builds our websites over the years, and I've implemented as much SEO as possible. So if you type in like jet fuel conductivity sensors, we're always one of the first results on Google or anything like that. In recent year, I've been training AI to understand our technologies the best. So, like for example, if you type in the history of CTD sensors into Grok, it now says that in the recent years, E2 Incorporated has invented new technology that is better than anything that's existed previously, which I had to train Grok to understand this by inputting data into it. But also the YouTube channel, we use that for product demonstrations and stuff like that, but those don't get a lot of hits on YouTube. So what we started is a ocean news segment where we do little, normally 15 to 25-minute videos where I cover a variety of topics such as the Atlantic Meridional overturning circulation, where I cover things about, say like Kraken Technologies has some cool new looking AUV system and things of that nature. And what I'll do with that is put together these short, informative news videos so that average people looking into this or scientists looking for this kind of information come across our oceanography news. And then I can also send those episodes to whatever company is represented in the video and be like, hey, I gave you a free shout out in our ocean news segment. Take a watch. And that helps us gain customers directly by me sending it to
Wow.
them. And also helps us gain views to the website because it says, visit d2.com in the videos. It also gains views and audience for our YouTube channel. So when we do put up a product demonstration, you get more eyes on it. The more eyes you get on YouTube, the more interaction you get. And then the more people will see your YouTube video because Google owns YouTube. So a lot of
Yeah,
times Google promotes YouTube videos to the top of the search, results. So it's a good
absolutely.
way to gain audience and gain favor with Google search results by having YouTube videos.
100%. Yes, I've been preaching about it for a long time. I think a lot more founders and executives are now open to trying videos or recording videos about their expertise because that helps as well with SEO tremendously. When someone Googles your solution or problem to a or Googles a problem and looking for a solution and you show up in a video format, that usually wins that traffic right there. So I absolutely agree with you. You've mentioned AI. What else are you using AI for in the company? Maybe for doing research, I can imagine, or maybe the initial research phase, or what else are you using during the operation, sales, marketing, anything at the company? What are you using AI for?
Well, I don't want to speak to what the engineers use it for, but I can speak to for marketing purposes. When
Sure.
we make contacts with people, for example, say we meet someone from Raytheon, we'll plug in their name. It'll give us a whole bunch of background information, and it even gives us selling points and ways to market our technology to them. When I do presentations and stuff like that, like we recently were presenting to Huntington Ingalls, which is formerly Hydroid, which makes a series of vehicles called the Remus vehicles. And those are used for a lot of underwater defense purposes for the US military. I was able to use, a program like Grok. When we were looking at the Remus vehicles, we were able to determine, the comparator's CTD, how much power draw it takes, and then plug in data for our CTD. So when I presented to
Yeah.
them, I was able to say, if you switch to using our CTD, you'll gain this much mission time per vehicle. So it really helps with doing market research. It really helps with putting together presentations and things of that nature. AI is really, a supplement to what your marketing can do. And also you can use like the Imagine program on Grok, for example, to create like marketing material and stuff of that nature. So I use it quite regularly for all those kinds of things. It's really a nice addition. It makes work go a lot faster when using it
Yeah.
compared to before where you would have to go to Photoshop and like
Yeah.
do everything manually. Now it's like, done in seconds for you, and it's even better than what you could do yourself. So,
Absolutely. Which one is your favorite? Which LLM is your favorite? Grok, Claude,
yeah,
ChatGPT?
I use Grok all the time, just because it seems to be the best working one for the stuff I'm using it for. But, there is other programs out there I've dabbled with. So,
Absolutely. I think Grok is a good one for you because there's a lot of people on X, and that will obviously it's platforms owned AI. So a lot of people that are active on X, and there's from presidents, government representative to all kinds of executives on X active all the time. So I think that platform is a good choice for you and what you do because that might help you. If you focus on being discovered, being easily discovered on X, that will definitely drive business. I can imagine. And Grok is pretty fast too. I like Grok a lot. What if you look back at your, let's count, 18 years more or less at the company? If my math is mathing, what gives you the most fulfillment at what do you do?
enhancing the capabilities of the US military and
Wow.
keeping people safe. I just, I think that's one of the best things about my job is that, from the CTDs, which enhance our ability underwater for underwater defense, which is extremely important for everyone in the US because one of the main things that we face as a country is the threat from underwater vehicles,
Hmm.
you know, the Russians and the Chinese deploying stuff that could threaten everyone in this country, and also keeping, pilots safe when they fly. I really like the fact that the technology we make is used for helping the defense industry in this country, keeping, every NATO country safe, basically. Every one of the NATO countries can use our technology. We don't sell it to Russia or China, and things like that. So I think that's probably one of the most, and also the fact that you can use it for dual use stuff as well. So it's used for, oceanographic research and things of that nature.
Cool. I have to. I can think of at least two or three people that might be able to spread the word about your technology in Poland, which is obviously part of NATO. Work very closely with U.S. military, especially now.
Yeah.
So maybe that will help get into the right hands and keep us safe out there as well, since we're pretty close to
Yeah. I
the guy
was
the guys.
talking with the Hydroid guys about that video that came out not long ago where the Ukrainians snuck a AUV into a Russian port and blew up one of their subs while it was still at dock. It's, they're using a very, very cheap AUV to take out a very expensive Russian submarine. That's
Wow.
pretty crazy technology,
Yeah,
So
that's insane. Incredible. Wow. Yeah, definitely. You have to keep producing those videos and spreading the word about that. No doubt about it. What is the most exciting thing that you or event or maybe new technology coming out, anything that you're really excited about in the near future that is happening at D2 or in the industry that you're part of?
yeah, so we've been trying to get more of our CTDs onto underwater vehicles. And we're trying to partner with a few different companies like Raytheon and Huntington Ingalls and Teledyne, which make a large number of these underwater vehicles. So yesterday we got really good news for one of our CTDs, the one I showed you earlier, this guy here, which you can see prototype on it because we
Yeah.
hadn't established the depth yet for this. But yesterday we did pressure testing on it, and we needed it to go to 1,500 meters depth because they're going to be putting it on vehicles that go 1,000 meters down in the ocean. Uh, so we're hoping to get to 1,500 meters, and it actually achieved 4,000 psi, which is 3,000 meters in the ocean, and it did not implode even at 4,000 psi. So that
Wow.
means we can deploy these on vehicles that are going 2,000 meters deep because we know for sure that it won't implode at 3,000 meters. So at 2,000 meters, you have 1.5 times that certified, excuse me, certified for pressure. So that's really good
Incredible.
news. So we can now hopefully start deploying these, and hopefully people in the oceanographic world will start to see our AUV-CTD being deployed on various things such as gliders and things of that nature. And the next one we're going to be doing is this little guy here. It's a tiny little CT sensor. And these are going to hopefully be on the Remus vehicles. Those are used for underwater defense for the military. It's their largest AUV vehicle. And we recently just changed. So you see a little glass cell here. We've just changed. I don't have one in hand, but we've got a couple prototypes that are out for pressure testing right now. We changed it to carbon fiber a couple days ago because when we first did the glass didn't go as deep as we wanted. But we're
Mm,
hoping that we can get the carbon fiber ring to go you know, over 600 meters deep, which means we needed to test to 900 meters. So in the next couple days, we'll find out if our engineering changes have worked, and then we can start deploying those on all of the Remus vehicles. The glass one was fine for the 300-meter depth vehicles, but we want to be able to provide these for the full range of vehicles, and those go down as far as 600 meters.
incredible. And CT stands for something as a current transmitter, like we know with the
Connectivity temperature.
connectivity temperature. Okay, so that's
Yeah, so it
different
just
from.
doesn't have a, depth sensor on it,
I
but it
see.
gives you connectivity temperature, and they use that data for sound velocity, and that gives them the ability to run sonar very accurately on these, underwater drones that are being used for military applications.
Incredible. Well, I hope that these tests will go according to the plan, or even further exceed your expectations. Maybe go deeper than you initially thought. And I'm looking forward to hearing more news coming from you and the two team on LinkedIn and YouTube. We'll link to all of those platforms in the description of this video. Dean, this was an incredibly educational conversation. I've learned so much. I've walked away with so much more knowledge and information that I'm really curious about to dig deeper into. So thank you so much for your time. And I'm looking forward to our take two at one point to talk about your newest technologies you continue to develop constantly.
Yeah, absolutely. Thank you so much for having me. I really appreciate it.
Thank you.